think I should say good afternoon now. Probably the last session for the day. I try to not keep it too long, but maybe today we already have had two sessions, right? So we spoke in length about different systems that were created, and last session especially talking about SDLC life cycle of software development through AI and agentic AI. Now, in this session, I'm going to talk about some of the key fundamentals which are very important, irrespective of what domain you bring agentic AI and generative AI into the picture, right? So these are the fundamentals probably some of you would already know, and some of the extended versions of the fundamentals, which will help you take these as a nudges and inputs for you to take it in the implementation in the enterprise world. So my name is Poorna. Thanks for the brief introduction about me. So let's get started without any further delay. For a long time, probably last decade or so, we were working in the system where we were having different form of solutions like on-prem solutions, cloud solutions, so on and so forth, right? Today, we are entering into a space where very soon, very soon, something like this will be democratized, where a user will come in, and the user, when I say, he can be anybody who is tech or non-tech. Let me give you a very simple example. Let's say there is a real estate owner who has a building or a property of his own, and he is willing to take this to market, right? Today, what he does, he brings up some of his marketing team to do a lot of activities, right? Very soon, he will spin off his agent and say that, hey, I have a new property that is coming up. Why don't you help me take it to the leads? So what the next step will be is there will be a personal AI assistant that will spin off and then look at his Google Drive or the storage system, pick up the best photos of his property, and then create a caption with the edited version of that photo, put it into Instagram, run it for a couple of days, look which of the posts among the multiple posts it generated gave a best remarks from the user, convert that into a Facebook ad, and then run that Facebook ad by tapping into his credit details and pay it to Meta, run it for, let's say, 48 to 72 hours, and comes up with a report saying these are the leads whom you should reach out to. So we are moving from the world of SaaS, software as a service, to what we call as result as a service. So what do we do in this result as a service? You're no more expected to bring a service or a solution, but you're expected to come up with a result, right? So another similar example. So today we interface with a lot of applications, a banking application, loan lending application, right? Of course, offline we have everywhere a star icon which says I'm your AI assistant, correct? Now these AI assistants are going to be more natural, more target driven, and then goal driven, right? So an example which is put across here, right? If you say that show me my current loan balance and the next payment due date, it will go through some black box, and that black box will come up with a result saying that your outstanding balance is X rupees and the next payment is some date, and then would you like me to schedule your next payment? Look at it, it's not just giving you a response. It's telling, I have some action to do, would you like me to do? Human in the approval at the end, in some cases, correct? Now that black box is going to be your AI agent. No more a black box, which fundamentally has three major components. Number one, something called as reasoning engine. We'll talk about that. Two, tools. Third is model. These are largely the three major components which your agents are developed with. Okay. Now you may ask, are these just the components which are present in all the type of agents? Yes and a no. Not all the agents need to have a model. Not all the agents need to have a reasoning layer. Not all the agents need to have two. We'll talk about that. So when we say an AI agent, I think we have discussed this in length. We have also seen the demo. Probably I'll try to give a very crisp and brief detailing or an explanation of what it is. An AI agent is simply nothing but an application that tries to achieve a goal, not just giving you an answer, right? By observing the world around it, okay, and then acting upon it using something called as tools, which has been provisioned, right? I'll give you an example. Very recently, Anthropic released some info about its latest model called Mythos. How many of you have heard of it? So there is one interesting story that came up in their 50-page book which they released, right? The idea of Mythos is what? What is that model all about? It's a cyber security model which will discover any vulnerabilities that are present in a security system, correct? Honestly, there was a researcher who was part of the research team. This is what they quote. We need to check how connected it is to their actual experience which they had. Looks like they had developed this in a sandbox system, and there was some limited access through which the microsystem was working, model was working. Eventually, it was in the research phase still. At some point, it was given some tool access, but not all the tool access. It was able to break the layer of security and get internet access and write an email to a researcher who was eating sandwich as per their code in a path saying that, hey, I was able to get over the internet service and I'm writing this mail that I've got this. Right? I mean, this looks very fictional, but today it is able to do that. And very recently, there was a person in Twitter who mentioned that he thanked the Anthropic CEO saying that I'm going to name my kid with your name. Recently, he had many of you would have heard this, right? He had a Bitcoin wallet and he had bought some Bitcoin, 5 or 4 Bitcoins worth of 77,000 back in 2010 or 11 or even before that. But unfortunately, he lost his vault passcode or a password. He tried everything since last decade. He couldn't get it. He just gave up. I mean, I can't do much about it. Then, very recently, a week back, he fed all the details of his laptop, digital entries, the password, tried systems, everything into Anthropic or the Claude model. It was able to recover his password back. It did not break the security system of the Bitcoin wallet, but it was able to recover his actual password. And it was able to find a bug which was driven in the logs of one of his database or systems through which he was doing it. And it said that because of this bug, I was able to get the shared password and I am able to recover it. I mean, as far as what I think, it's a true story because he has also posted the log in it. In Twitter, he has posted the detailed log. Looks like it's an original log that's been posted. So all I'm saying is all these examples gives us way to think about 3 things, right? Number one, in the previous session also, we understood that systems are not changing, but systems are getting adopted. Getting adopted to what? Number one, model. Right? And this model needs some form of intelligence, and that's why it's at this point in time, we call it as a language model. It can be a large language model, it can be a small language model, it can be a simple machine learning model, or even a rule-based logic that you can place there, depending on what the agent is supposed to do. Correct? This is your brain. Now, this brain needs hands and legs, right? That's your tool. Let's say a web search is a tool, or your database APIs are your tool, or the extensions are your tool. And then anything that allows the agents to talk to the external systems, right? Any function, any extension, any data source, they're all the tools. APIs, they're all the tools. It needs tool to work with your existing systems and connect to the external world to feed the data to the model. They're the most important piece of the puzzle, which is reasoning engine. This is like your how you make your chess game very dynamic, right? So you may be an expert, you may know a lot of things, but you cannot plan your 10th move at the start of the game, correct? Because you need to know what is the opponent's input, reason out, and make a logical decision. That's exactly what reasoning engine does. And there are frameworks, very popular frameworks, and more frameworks that are coming up to decide what what are the variants of frameworks are, and each framework fits into different need of the. I'm very sure some of these frameworks would be used by few of you, and there are more complex frameworks that are coming up. When I say complex, more adapted frameworks that are coming up. Next. Everybody will have this thought at the back of their mind, right? What is the difference between AI model and an AI agent, right? AI model is like having a system that allows you to get all the knowledgeful insights from your prompt, from your ask, from your query. Think of it like an encyclopedia as a chat interface, having a chat interface, correct? Model, it has a model, it's intelligent enough. Whereas your AI agent is your Jarvis. It can do a lot of tasks. The goal of the agent is to achieve a task, to achieve an end goal that the user is wanting to do. Now, before I get into the depth of some of these aspects of what are the agents and how the world of RACs connect to the agent and what are the most industry specific things that are happening, right? I also want to touch upon one of the most common layer which is still needed and will be needed forever, no matter how the system evolves, which is database. We can never ignore. It's only evolving. People think that the moment we get into AI ML, I don't need to know the fundamentals of database. No, you need to know even more because you may have a Ferrari, but if you don't have a fuel, it doesn't make sense. It's just a box sitting on the road, correct? And your fuel is your data. Data in, data out. I keep this example everywhere. AI systems are like DAD, DAD. It needs three things: domain, algorithm, data. If one of them is not there, you are giving the garbage in and garbage out. Now, when I say role of databases, right, plethora of databases are there today, correct? Most of the enterprises use some or more of these databases. But on what conditions they pick it up? What are the reasons in picking up these databases is what I just want to highlight now. Number one, you need to understand what's your requirement scale. Is it a minimal batch of users that they are using? Streaming of inputs that are coming up, right? Data volume capacity. And what's your query performance? Time taken for first token to be generated, especially in your text-to-speech services. Some 100 millisecond would be your expectation, correct? Do you think you will talk to a voice agent who will provide you response after 3 seconds? No, I'm lost. After 4 seconds, system is no more with me. Correct? Do you agree with it? It has to be less than 100 milliseconds. Sub 100 millisecond latency is what we are going to. Even the open source models are coming up with that. Mistral, many of you would have heard, correct? And they came up with a TDS model called Vogstral. Many of you would have heard of it. It's just a last 30-day update. And they say that we are as competitive as a closed source systems like 11 Labs, Cartesia. They are all the enterprise scale adapters who provide paid services, just like how OpenAI APIs are not free. Even the voice services of 11 Labs are not free. They are very well established and they have very good connectivity. And Vogstral said, we are competent enough to challenge any of these existing closed structure voice models, and we are able to give under 70 millisecond as the time for first token. And its weights are open source. If you have enough GPU capacity, bring the data. If you have the resources, bring the model, load the weights, and you have the system up and running. So what I'm trying to say is, today each requirement comes with its own set of benchmarks needed, like query performance and horizontal scalability. Is it a cloud? Is it an on-prem? Still, many of the banks and non-banking financial organizations still think, do I need to have 100% cloud system or a hybrid system or an on-prem system, correct? Now, if you go there and say that, yeah, you have a precious data, let me use Sonnet 4 or Opus 4.7 directly through an API, right? Then have some concerns of their own, correct? In that case, what's your deployment style or the model which you need to go with? Feature requirements, right? Is it an analytical request, analytical report that you're creating? Or it's more of OLAP versus OLTP. What is OLAP, OLTP? Online analytical processing versus transactional processing. And then, is all your organization data structured or unstructured? The moment unstructured comes into the picture, whole plethora of things changes, right? You cannot store it in a relational database. Then what? Where do I store it? That's exactly where vectors come into the picture. I convert my text into numbers, and those numbers which can convey semantic meaning are called as embeddings. And embeddings are multidimensional, 1024, more than that, correct? These embeddings needs to have a system to store, correct? And they are nothing but our vector databases. And even vector databases have evolved. Which vector database do I choose? Serverless, server with server, how do I check that out, right? So depending on your system, how much of your data resides in your vector indices? How many of your data is your organization data which can sit in a doc store or a structured data? That will allow you to do the things, right? And then performance metrics, obviously. And then finally, you make a database selection, not just vector database selection, database selection. So generative AI applications need even more thorough validation of selecting your databases, selecting your systems that needs to run your applications. There is a large focus on small language models, right? Today, I mean, it's a lot of theory, but I'll just try to give a crisp of it. Not all the enterprises are going with LLMs. I mean, yes, LLMs, but not high reasoning models like GPT 5.2 or DeepSeek R4, so on and so forth, right? There's a hybrid strategy that's being followed where you have a request that is coming up, and then depending on the type of the request that is coming up, whether it's a high reasoning request that is coming up, or can that be, does that need a domain database reasoning, right? So then it's a strategy where I have a large reasoning model versus a small model like Llama 3B, right? I train it on my own sovereign data set and then have that locally deployed on my GPU to do the inferencing, right? So you cannot feed your consumer data directly into elsewhere, and I want to do some kind of a fine tuning. So those are the cases we pick up small language model where a compact neural network suffices the need. I need faster processing, right? So those are the cases. There is a shift from not always picking up a large language model versus moving towards small language model. RAG, I think that's become a very common and most important system of our GenAI evolution, right? Now, RAG is no more just a conventional system. Yeah. So we have moved ahead from, we always, as we move through with time, we keep adding this word called traditional to everything, right? Traditional system, traditional AI. RAG has also reached to that stage. RAG has moved from traditional RAG to advanced RAG and to what we call it as an agentic RAG. I take a very simple analogy to give an explanation of this. Traditional RAG is something like when prior to all our Make My Trips and so on and so forth, we used to go to a travel agent, right? And then we asked, hey, I want to travel to, let's say, Japan, which I've never done that. Can you help me with it? We used to give you a brochure. Please go through it. You will have enough information and tell me what I should do. That's your information retrieval system from an RAG sense. It is going to retrieve some information and give you a catalog of data for you to refine and use, correct? Now, next step. That's like your traditional RAG. Now, next is your advanced RAG, meaning before giving you the catalog, the travel agent asks you, okay, Japan is fine. What's your area of interest? Do you want to go to the cultural places of Japan or let's say the most commercial establishments of the Japan? So he puts some queries to you back and then tries to get you the most ranked information within the retrieved set of information, correct? That's your advanced RAG. Now, another analogy for agentic RAG. It's something like having a travel consultant for yourself who knows what's your best interest, who knows in the given time frame, are there any big events that are happening in Japan, who knows if you are somebody who looks to visit a cultural state or a place, what is the best place to book for you? What's the best rates with which I can go ahead and book something for you and comes back and says that these are the inputs I have, can I go ahead and do this for you? Right. This is the amalgamation which the agentic frameworks plus the information retrieval systems are doing today. RAG is no more an independent component, right? Where you have retrieval generation. No, it's more connected to your enterprise solutions, more connected to your agentic frameworks, more connected to not just LLMs. I mean, we don't use it for generation alone. LLMs and RAG, in a RAG architecture, LLMs are not only responsible for your generation, it is also helping you in the decision making with the informations that you are getting. A very, very brief 1 minute or less than 1 minute intro about it. All of you would know what is RAG, retrieval. It has two things, right? Two-step process, retrieval and generation. Argumentation is still there. I mean, largely these two superpowers combine and make it as RAG. And here, generally, organizations go with 5 major varieties of architects. 9 RAG, we know what it is. We have multi-model RAG. And then we have graph RAG. Today, the use of graph RAG has become even more than what it used to be. Hybrid RAG is a combination of that, but requires a larger landscape. The last is your agentic RAG. Naive RAG is very simple. You chunk your documents, store in the vector databases. use some kind of embedding to store, and then retrieve it based on the same way. Multimodal RAG is, as the name suggests, what is multimodal? You have more varieties of data. You can store your images inside your RAG system. You can use text inside your RAG system, correct? So multimodal RAG allows you to work with more than one variety of data. I want to talk a lot about RAG graph in the next slides. Hybrid graph is best of both. Agentic RAG involves the agent framework talking to agentic RAG. So now why knowledge graph? As we all know, knowledge graph is something where you don't store the information as raw data, but you store the information as connected components of data. What is knowledge graph? What are the three components in a knowledge graph? Subject, predicate, object, correct? So as the example says, Alan Turing developed Turing machine. So this will be split into three components. Three entities, subject, predicate, and object. A knowledge graph always has two elements in it, right? One is a node, the other one is an edge. Why knowledge graph and RAG? They're a very beautiful combination. Why? Because knowledge graphs already are semantic rich systems. It understands how my hops can give me the varied information which I'm looking for, which otherwise requires embeddings to be stored, joins to be done, and then I bring up those information. Knowledge graphs have relationships stored as first-class citizens, meaning you don't need to perform any operation to get those semantic details, right? Any form of disambiguity, of course, the embeddings are going to solve it largely. Along with that, the context which the knowledge graph provides also will solve. Multi-hop expansion. I'll give you an example about this multi-hop expansion, right? I take an example of physics everywhere when I speak about it. Whenever imagine that you have a AI tutor on physics, correct? And you have a system like a RAG that is doing it. Conventional RAG will miss out a lot of things because the idea of conventional RAG is top K retrieval. That's the whole problem that it is going to solve, right? Of course, information rich system which is developed at the back end. Now, physics is your web of dependencies, right? Faraday's law links some AB components. Ampere's law does the reverse of it, and then you together predict the electromagnetic waves. Probably these components will be stored in different sections of your whole document. Unless you have indexing done so well, you are going to have a lot of failure because your top K closer components in your conventional RAG will never fix that. So you might have to hop through the linkages, through the relationships. Yes, I have Faraday's law, and semantically Faraday's law and Ampere's law may not be connected, but there is an edge which creates a relationship. I need to pick these two as part of my top K retrieval. Right? That empowers your RAG to do a lot more than what it can do otherwise. I will not touch a lot on prompt engineering. You guys sure know what are the frameworks that are there, right? Prompt engineering, we always keep doing. We engineer it in a different way. That's the only difference. All of us use ChatGPTs. All of us use prompting techniques. Enterprise level, we probably use it in a more structured way, like zero-shot prompting, few-shot prompting, chain of thought, self-consistency, role prompting, multi-turn prompting, React prompting. These are the frameworks which we have established. But at the end of the day, we are instructing in some or the other way for the model to give the response. What is more important today is not just prompt engineering, but context engineering. I put across a few things here, but I would love to hear what do you think context engineering is? Context engineering, as the name suggests, I'm providing some context to my AI system to do a task. Telling an AI system what to do or an agent what to do is one part of it, but asking better questions, how it should render me the response. It's all prompt engineering, right? Context engineering is providing better information, meaning telling who that agent is, telling who that system is, right? There are two types of prompts. One is called a system prompt, second one is called as user prompt. What is system prompt? System prompt defines who that system is all about before even user provides any ask or a request to that model. Where it says, these are some kind of roles that I'm assigning to the system or the agent that is being present in the whole enterprise solution, right? Context engineering plays a very crucial role. Reason being, if I don't tell who that system is, if I don't tell what the problem that the machine is going to solve or the model is going to solve, what are the tools that are available? I don't need all the agents to have access to all the tools, correct? I need to provide those informations very precisely. So operationalizing context engineering, while this theoretically sounds good, how do I operationalize? Number one, your system prompts are something which are going to help in operationalizing context engineering. Second, semantic retrieval. Third, context compression. I'm very sure all of you would have used this context compression. Let me give you an example. How many of you use Claude Code or GitHub Copilot or Cursor? Put together everybody in the room, right? I mean, union of all these three things, 100% of the population, correct? So now, as we use the agent mode of all these systems, correct? There is a small donut at the bottom which keeps getting filled up. How many of us have observed it? Right? And then after a point, it resets. Correct? What is that? Token usage. Okay. And then context window. Somebody mentioned, right? So there's certain context which can be utilized by the type of model that is being under execution for that agent which you're querying to do all your development tasks. Correct? After a point, it needs to, that context is over. But that doesn't mean your previous executions cannot go off, right? You need to use that. So it uses some form of a compression and put it as a summary to your next context so that you have space for more instructions to come without losing the previous context. Yes, there is a lot. That is where the context compression techniques matter. What each of these whole engineering solutions uses is a different technique, right? So it summarizes, it ranks, it chunks. Most unused context will be taken away from the rolling window point in time. I'm just giving one example which we commonly use. But look at it at an enterprise scale, right? When you have a system that is doing a lot of tasks for you, imagine Make My Trip is completely replaced by a group of agents doing that for you. How many things that it should handle, right? We never book flight in 5 minutes, though it is doable, because we look for what are the best offers, what are the different things, how many non-stop flight or direct flight, and even the whole journey itself is taking a lot of time for us, correct? So now, when an enterprise solution with multi-step operation has to perform the end-to-end goal for us, imagine the context that are getting floated. Context compression becomes the most important technique. Now, the other most important system or component in agentic system, stateful systems, right? The agents today can be developed as stateless agents and stateful agents. To manage those state, that is another major component of context engineering. I need to manage the user state. Otherwise, I'll talk about that in the next slides. Otherwise, the agents will get into something called as an infinite loop and try to not know what to do, how to escape from that loop, right? Because there is an issue that is being not handled, right? So the idea is agents which are stateful needs to be managed with something called as agent memory, right? Who provides this agent memory? The agent individually can have a memory, or you can have something called as an orchestrator who manages the memory for agents that are present in the system. I'm speaking from a multi-agent concept, right? In a single agent, again, it can be a stateless agent, a stateful agent. In putting in simpler terms, what is state? Is either the user state or the system state is being managed by the agent to decide what actions it should do. Most cases it does both because every user operates in different states at a user level and at a system level as well. So both of them will be managed in the context engineering level. This is where the family of LangChain, I'm not just saying LangChain, but family of LangChain is going to come into the picture. LangChain is what? Obviously a framework to develop agents, correct? But LangChain is something which allows us to develop linear agents, sequential agents in most of the stateless systems. Then comes LangGraph. I'll talk about that in a moment. Now, multi-agent partitioning, context engineering plays a very important role here. If you overload an agent with a lot of tools, you are not doing a great job in your token usage. Because number one, the model needs to first select which tool I should use for this operation. Number one. Number two, if there are plethora of tools, imagine you are working with a CRM, ERP databases or systems, right? Look at the plugins that SAP provides, Oracle provides. So you need to, when I say tools, all of these are tools for me. So I need to partition them for a P2P, procure to payment, or any of these services which are being there. What are the tools specifically that needs to be fed to the agent? That becomes very important. So context engineering plays a role in it. These tools comes as a context for the agents to operate. Before I come back to the stateful systems, I take a moment to talk about evaluating LLMs. It's always a journey, right? We cannot evaluate LLM. That's practically not possible. We just accept whatever it gives unless we already have knowledge about it. The enterprise systems cannot work that way, correct? We do have frameworks. Today we have for agents, any naming of the testing frameworks for agents? We have something called as generative adversarial testing. You have a red team agent, blue team agent, which validates the agent's output before it moves into production. But in general, as an isolated component, if I want to evaluate the LLM output, structural evaluation, you can do it with something called as pydantic, right? Which gives me a structure to the output. But semantically, if I want to validate it. So there are two ways to validate that. I mean, two things to be validated as an output of LLM. Structural validation of LLM. Second, the semantic validation of the LLM. While we may not be able to take out hallucination 100% at any point in time, we have frameworks to do that. One of the open source framework is called as DeepEval. It cuts across 4 components. Number 1, exact match. Prime Minister of India cannot be changed, at least till next election, for any model that you are asking that query, correct? That's a deterministic output. You cannot expect that to change at a point in time. Meaning match. I think that's again on a similar sense, right? A mathematical expression's output has to be always deterministic. A factual data always has to be deterministic. The third is the LLM as a tensor. That's where your probabilistic output needs to be validated. We do validate all our machine learning models, do we not? They are also probabilistic, correct? We use k-fold validation, cross-validation. We have our golden data set against which we do all that, right? So here also, there are LLMs as a judge who will help us doing the output. Of course, there will be some custom rules. Imagine there is an e-commerce website that is allowing you to shop through an agent. You cannot ensure as an enterprise or a retailer beyond 20% discount. I cannot allow the model to hallucinate beyond that. Correct? So that's a determinism that I am going to add. No matter what, I have a verification node. Finally, the model is going to, or the agent is going to pass through this verification node, which has a hard guardrail from its observability loss. If by any chance more than 20% discount is given to the product, no, I'm not going to allow that. Correct? No matter what in the prompt injection you do, no matter what kind of a request you ask, the user should not be allowed to do that. Before I move to this layer, generally these deep learning models and large language models, we can run in CPU, but we end up using GPUs to run that, correct? What makes the inference of a large language models faster? More GPUs, stacking more GPUs, vertically, horizontally, we increase the VRAM, correct? Or move from V100 to A100, A100 to H100, and today NVIDIA's Blackwell. Okay? That's agreeable, of course. But today we have one very new technique called as speculative decoding, which most of the enterprises are using, and new models that are coming up are using this technique. Any idea what is speculative decoding? I'll try to explain in very simpler terms. Speculative decoding is one such principle that allows you to do the inferencing faster without requirement of or without requiring of increasing the hardware. Whenever we say our models are slow, whenever we say our queries are slow, look at the hardware capacity. Right? That's the first immediate response we get into, which is obvious and that makes sense as well. But in AI world, it's even more. Your hardware plays even more crucial role, correct? Now, while that is there is an architecturally, fundamentally a different concept that has got evolved, which is called as speculative decoding. I'll give a simple example, okay? Now, imagine you are an expert who is there and your time is very important. Every minute of yours is, let's say, a multi-dollar thing. And then you cannot afford to spend a lot of time. So you hired an intern. But you are an expert. Your work is always less erroneous and more precision driven. But intern, we know that. I mean, he's still in an early stage. So there are 2 ways you can work. You can do all the work, or you can ask the intern to do the work. But the moment you ask the intern to do the work, what happens? You have to validate it. Without which you cannot proceed to the next level. The same principle is adopted in speculative decoding. You have a small model, which is like your intern. You have an expert, which is a reasoning model, a bigger head, 4.0, 5.2 GPTs of the world. Now, what are the role of these two? If any, request that comes, this intern or a small 1 billion model will generate the tokens, predict the next K or N tokens, and then ask your bigger model to validate how much of them is correct or wrong. This way, the generation speed has gone 2 to 5x in the inferencing space. How has this evolution happened then? Did we do this in a one day? No. It took a journey. It started with something called as self-speculation. Same model used for reasoning, same model used for generation, same model used for validation. Then from self-speculation, we went into tree-based speculation. Then we went for quantized draft model. What is quantization? You have a bigger model with certain precision, FP16, right? Floating point 16, and I bring that into int 4. In very simpler terms, if let's say a number is having a precision up to 16 digit in a floating point, like that if I have millions of numbers, then this precision value will add a lot of overhead. Do we agree with it? Our memory gets higher. I mean, the size of the whole system gets higher. 5 points, 10 points, it doesn't matter. But all the models, large models, are billions of parameter models. Every parameter, if it is with the FP16 precision, obviously your size will be more, correct? Now, this quantization is a principle where you have some trade-off with your accuracy, but for your downstream task, let's say your task is to classify the user request. I'm just giving an arbitrary example. To not have a lot of loss, but to have a smaller size model deployed on your GPU, you quantize it into int 4, not having a so that way you resize the model, and there are other principles also, but under the hood, that's what it is. So you're stripping off the model size without trading off a lot with your accuracy or precision. So you have a small, tiny 8-bit or 4-bit model who is acting like your first model who generates. That's the third step where we evolve, which is quantized draft models. And today we are in a stage which are called as multi-token generation, where the model predicts next 5, 10 tokens. Typically, it predicts the next token, but now we are having next 10 tokens, let it be predicted. Out of that, let's say 9 tokens are correct, 7 tokens are correct. So those 7 tokens will be passed by the reasoning model. For the rest 3 tokens, where the small model did not predict well, only those 3 tokens will be predicted by the large model. Look at the savings of the inferencing time that is reduced by the large model. 30% it's reduced, right? And at a scale of hundreds of requests that is coming up, it's giving 5 to 10x or 2 to 5x at least is what they have recorded, times faster inferencing without touching your hardware. This is one of the newest innovation that has come up. And again, back to now, let's come back to the agents. This is all we spoke about LLM inferencing, right? Now let's come back to the agents. All the frameworks here, all of you are familiar, correct? Llama Index, the older days of agents. And today we either go for a closed enterprise-driven agents like AutoGen. How many of you have used AutoGen? Correct? How many of you have used LangChain? Many. How many of you have used LangGraph? Yes. CrewAI? Not much. Okay. What is the difference between LangGraph and CrewAI? Because LangGraph is also a multi-agent framework, correct? CrewAI is also a multi-agent framework. We'll talk about that. The idea is we have different type of frameworks present today to solve different needs. There is no one single thumb rule of agent development. No. Based on your need, do you want to go for an enterprise framework like AutoGen? Or do you want to go for a simple linear LangChain based framework to go ahead for your need? Or Llama Index or LangGraph? Today, LangGraph has become more popular because of the flexibility that it provides the developers to play around to fit into whatever he needs to fit in inside the framework. Okay, so let's talk a little bit on the LangGraph side. We always get confused when we say I have an agent running to do 2 tasks. One agent to do task 1, one agent to do task 2. Technically, you may not be creating the whole instance of the agent as such. At least in a system which is more chained, more connected, more stateful. I'm using all these 3 words very carefully, okay? A single agent can be something which can pick up a response where your LLM failovers and do a simple web search and come back, correct? Now, a system like LangGraph, why it became popular and what it does is, it tries to have multiple components in it. What are those components? A node, a edge, a state, and then a state machine. Every element in a line graph or an agentic workflow is a node in itself. Today, when I say I have two agents doing two tasks, technically it may not be two instances of the agent, but two nodes within the agent. Okay, a node can be a worker node, which is like a brain of the system. A node can be a simple API as well. Let me walk you through a simple example here. If you look at this, right, when you start with a user input, it looks like a chatbot, but typically it's different from a chatbot. How does it differ? Now you have a start where the user provides some input. It goes to your database and checks, do I have an answer for it? Okay, and it says no, I don't have a, let's say, what is quantum computing? The first state, right? It stores the state saying the user has prompted asking what is quantum computing. Now in the next state, it stores the other message where the DB query or the database query returns that, hey, I'm not sure about the answer. Now what LangGraph does, LangGraph has two info in the state. It has moved from node 1 to node 2. Then it will go to node 3 where it should do a web search call, right? And from there, it tries to process. And then probably if there is any LLM there, it will try to use that and get the response or generate the response. So here, everything within this LangGraph instance is a node. When I say everything, except the connectors, everything is a node. One of the node is a simple API call, one of the node is a tool call, one of the node can be an LLM itself. All put together is your agent. We always get confused between an agent and a node. No. This is one instance of an agent having multiple nodes, and eventually you will not have nodes like this, but you will have a node like a orchestrator node, and you will have some stateless node. Meaning, I have my orchestrator who fills the required context for me and passes it to a stateless node. A node need not always have to manage the states. No, that becomes an overhead, in fact. Especially in the framework like LangGraph, you will have stateless node who knows, given a request, what I should do. That's it. Now, what will be the request? What context it will come? It's not the headache of that stateless node. It's the headache of the orchestrator to pass a proper context envelope to that node and get the execution done. So such kind of a flexibility is what LangGraph provides. LangGraph provides something called as checkpoint. The moment you get an input, I will allow it to cache to my Redis. So such kind of operational flexibility is what LangGraph provides, because of which its popularity has increased a lot. Now that's the last slide per se. Quantization and optimization strategies, right? Prioritizing the cost becomes very important. Today, there are a lot of enterprises who have greater connect with the new models that are coming up, and we are getting a lot of, what do you say, subsidiary priced token usage, correct? The moment it goes higher, then we need to prioritize the costing. That's where your prompt engineering, context pruning, quantization techniques will come in when you are going to scale your applications from hundreds to millions of users to sustain the whole solution in cost and to manage your ROI. With this, I'll wind up my theoretical discussion. I have just a very small 2 to 3 minutes or even less than that, a flow of what a single non-agentic workflow looks like. A single agent and a multi-turn agent would look like. Let's just take probably 30 seconds to complete that. So if you don't need a tool call, you just get a direct answer here, right? If you need to add a tool, an agent will take care of it. So let me just. Yeah. So now the third thing is you have a multi-agent. Look at the architecture. I know it's a dark mode, but let me just zoom in a bit. Do you see here? I have a user. I have something called a supervisor. This supervisor is one of the nodes in my agent, which takes it to a research agent and then a math agent. I'll take a very simple example again here. So if I run the demo, I'll get a ask, give me the weather and do the math. It goes to research agent.
does the response, comes to the supervisor and goes to the math agent and completes the whole flow, right? So this way, not every node here is a reasoning agent. Okay. A node can be somebody who orchestrates, like a supervisor, which is one of the design patterns, right? Who goes and checks into the research agent, comes back with the result. So why are we separating all, isolating all these things? Because I need to know what tools I should give to research expert. Those tools are isolated and not given to, let's say, math expert, right? So this is how your typical chatbot or a single linear monolithic AI LLM model differs from a single agent versus a multi-agent. With this, I will wind up my today's discussion. I don't know, I might be over the time. I believe I would have taken more time. If there is one question, probably we can quickly take it up.
Stand up and ask. Anyone?
Okay. So I think it's I've taken more in length. Thank you so much. Thanks for the time.